Hey guys, so I wanted to go over a little more homework with you. First of all, this is a competition, a graded thing. It's between a student, a hypothetical student, and professor, and the student has to get a 95% confidence agreement with the professor in order to pass. I know it's stupid, but oh well. Let's just go with it. You don't have to agree with me. So the student, uh, we'll call him the stud here, is 5.480 plus or minus 0.209 after 6 trials. This is, some measurement that he's making. It's called parts per million, whatever. And the professor is 6.130 plus or minus 0.120, also with 6 trials, right? And the first thing to do is to compare the standard deviations. And so that we do by dividing them such that the quotient is above 1. 0.209 divided by 0.120 is equal to 3.033. And we're going to compare that to an F table here, which is, let's see here. The F table is here, and the F table is for 5 and 5. So it's 5, 5, F. And we're going to look at 95% confidence. And this is a whole tables for 95% confidence here. And so that critical value is 7.15. And since our F calculated is less than F table, we conclude that the standard deviations are statistically identical. So our calculated is less than F table, therefore standard devs are the same. Okay. Now the next thing we want to do, we want to use a t-test. And by computing a t-calculated, right? And that is going to equal x bar 1 minus x bar 2, absolute value of, divided by s sub p, the pooled s value, and then times n1 times n2 over n1 plus n2, square root of, and where s pooled is equal to s1 squared n minus 1 squared and 1 minus 1 squared. Oops, sorry, not squared there. Plus s2 squared times n2 minus 1, all divided by n1 plus n2 minus 2, and the square root of this whole package. And so this is S1, this is X bar 1, this is X bar 2, this is S2, right? So we substitute them in there, and S pooled comes out to 0.406, and we put that in the denominator, and we get T cal is equal to 0.640 divided by 0.406 times, this mess here is 1.73, that is equal to 2.77. Therefore, at 95% confidence, there is no difference. So, oh wait, sorry. No, I jumped the gun. That's 2.77. What we need to do is look at the T table. Sorry. So the T table value here is, let's see, what's the T table value? And what we want to do is we want to look at the T table values for 95% confidence and N1 plus N2 minus 2 and 95%. And this is going to be 10 degrees of freedom, 95% confidence T, and that guy will equal 2.228. You can see it here. It's this guy here, 2.228. Right? So go back to the camera here, and T table is equal to 2.228. The difference is 2.7. The T value difference is 2.77. So therefore, there is a significant difference. At the 95% confidence level. And that is the answer to this homework.